Good afternoon, YouTube. Greg here from GregsTutoringNYC. What's up? What's up? What's up? So, we're doing the so-called hardest math problems. I'm doing a series. I already did grade 3. I already did grade 4. I already did grade 5. We're already on part 4 of grade 6. There's a lot of problems. And I chose to define hardest as the hardest math problems, the number of kids who got the most problems wrong on the New York State tests. Okay, I'm trying to make this not about New York State tests or about testing. I'm trying to make this about problem solving and things like that. In the event, we're going through a lot of the problems. They're getting deeper and thicker. As I introduced in the beginning of this grade 6 section, you're now in middle school, and kind of the problems bump up their game. And the next one we're going to do, hopefully I'm going to get this all done today. I don't know how. This stream might go to 2 hours. If it looks like it's going to, I might split it into half. I'm not 100% today either, so I might even just go 45 minutes and split it in half that way too. So we're just going to feel this out. We're going to do the same as some of the other ones. We're just going to start chugging along over problems. And hopefully these are useful just for doing your homework, just for trying to understand the concepts and trying to figure out like alternate ways to view the problems. Because in class, you're often given like robotic instructions to follow, and that's cool. And you're often given stuff you need to memorize. A lot of it's rote. It's just following procedure. But I'm trying to put another spin on it, which is trying to get you to identify, to even understand what you're being asked to do, opening up a problem-solving toolkit, and just thinking about what's being presented with you, to you. Not just trying to follow, oh, what did my teacher say to do? Really try to understand what the problem is asking of you. Try to understand the English. Try to understand the illustrations. Try to understand what the question choices are even. Okay? And then you have to do a mapping from the English into something conceptual. Math is conceptual, right? So whether it's geometry, triangle stuff, which is called trigonometry, algebraic stuff, which involves symbols and unknowns, or arithmetic. So most math problems, no matter what topic they're about, arithmetic is a given. You're still going to have to do a calculation, a multiplication, an addition, an exponent, whatever the case may be, right? So you're still going to be stuck with that. All right, so that's the kind of stuff I want you guys to get into. A lot of you guys might do homework or take a test, and you might be like a 90-something student, and yet you make a lot of silly errors. Okay. Oh, I got off by 1. Oh, I forgot to divide by 2 at the end. It means you're not being attentive. It means you're not following the problem completely. You're being distracted, things like that. And there's ways to get around that. So what I'd like you to do is, as you observe how I solve the problems, really do that. Really say, why is he saying that? Why didn't he do it this way? And why, and I'm gonna give you some of those choices sometimes. So in as many cases as possible, I'm gonna try to show you alternate ways to solve these, including logical ways. Okay, and a lot of your classes, especially since Common Core came into being, a lot of you guys are being asked to show your work, prove it, that kind of a thing. That has its place. Don't get me wrong, but there's also nothing like innately understanding math and things like that too. And they work in combo. You just can't show the work all the time because there's certain kids who are accelerated or just think different. And when you force somebody to do it a certain way, it can become boring and frustrating and all this other stuff. So what we need to do is be malleable and adaptable so that we're kind of getting all those different ways and different places to do solving the math problems. And if you since math is conceptual, it's abstract. So we're not always solving concrete things. I can hold up this pen and say, look, I physically have a pen. This is a concrete thing then. I can put it down and we can start talking about things. Like we can start talking about circles. But the truth of the matter is none of you have ever seen a circle. A circle is a concept. There's no real circles in the real world. Okay? So those are the kind of things we're dealing with. And then we get into algebra, we're talking about things conceptually. Like if I have 3 things and I add 3 more things, how many things do I have? Enough of you probably know there's 6 things. And you can do that without caring what the things are. I could have a doohickey, a thingamajig, or a pen, right? And you would know if I have 3 pens and I add 3 doohickey's to it, I still have 6 things. I don't have 6 pens, but I have six pens plus doohickeys. So there's ways we can talk about stuff and solve real world problems, whether it's building a bridge, sending a plane into outer space, going underwater, just even doing financial stuff, running the stock exchange, running a business, ordering supplies, buying something, the internet, your computer, your phone. So there's all these different choices. By the way, let me just make sure that we're live, and once I do that, we're going to jump right into this. Okay, we're good. By the way, please like and subscribe. Okay, I have pump out a lot of content for you guys. It's all free. It's all free, right? So please subscribe to the channel so you get notifications. Please like. It helps the channel. It doesn't help me directly. I'm not monetized, so this is all completely free for right now. In fact, anybody wants to go to GregsTutoring.com/gift, you can make a donation to me if you want. So this is free to you guys, but it's still an expense for me, and not just time. I need computing power. I'm et cetera, et cetera. I need internet connection. Sometimes I need a service provider, stuff like that. Okay, so with all this background, we're going to jump into the problems. The way we're going to do this is I'm just going to go from problem to problem. If you guys have questions, definitely ask them. Okay. And if the question is not about what we're talking about, I might still answer it, or I might wait until the end of the question, or I might answer those questions at the very, very end if there's time left. Okay, so yesterday, I think we only did like a 45-minute session. It turned out I had to go somewhere, and I scrambled out. So I do believe I answered this, but if anybody is watching part 3 and doesn't think they have a sufficient answer, you can definitely email me. I believe what I did super quickly, and let me get my pen live here. Is I determined this was 6 and this was 3 here. Okay, and I did that by factoring 18. The factors of 18 is 1 and 18. So I'm just continuing on from the discussion yesterday, right? 2 and 9 and 3 and 6. Okay, we're looking for whole numbers. It could turn out that they're because we're trying to shoot for this area is 18 square centimeters for the surface area of this area right here. Okay, so 3 and 9. Oh wait, sorry, 3 and 6. So they could use fractions and so on, but we're assuming they're not. Okay, so once you build this table, what you want to see is which of these, and because you know this is smaller than this here, you're going to pick either 1, 2, or 3 here, because that's the left-hand side bunches of choices. Okay, and then since this is 12, what could work with that? Or another way to say it is, what's the factors of 12? So that's 1 and 12, right? 2 and 6. And 3 and 4. So 2 and 3 both match, right? So what we have to decide is whether this, whoops, I don't know what this thing just did there. That should be disabled on this. Let me change the color of this too. So this and this, and I'm doing in the light green right now, they're the same length because we decided it was a rectangular prism. Okay, so we know they're the same length because of that. Remember the discussion from yesterday. So we think the green length here is either 2 or 3, and then that means if it's 2 or 3, that this would be 4 or something else. And it turns out that when you go through all that and get all the numbers, you'll end up with the choice down here. So this is a nasty problem because it takes a lot of time. And almost all kids got this wrong. All right. So it's 3, 4, and 6 is the answer. And once you get one, you can test it. So if let me use a darker color. Let me use purple here. So once you go to that, if the length of this is 6, right, then the length of this, let me write it down here because is 3. So 6 times 3 is 18. So that means the length of this is 3. And if this is 12, then this is 4, right? And it jives because if this is 6 and this is 4, then 6 times 4 is 24. So that means we covered this, we talked about this, we talked about this, and we talked about this. So that leaves this square rectangle here, but that's the same as this one here. Okay? And then this one is the same as that one, because that's the top and the bottom, and this and this and this were the two sides. Okay? So this is probably one, it's not that it's hard, it's tedious and meticulous and error prone. Okay? So that's what you guys got going through. And again, if you should go and see what I did yesterday, because I didn't end it yesterday, I'm kind of ending it now. So the conversation yesterday came up to the point where, and I just answered it. I answered it okay, but I answered it quick. And today I'm just starting at the end of it. So if you watch the two together, you should get it. Okay? Correct. So we have problem number 19 here. Same spiel. We're going to look at the illustration. So we have a table with 2 columns. It doesn't have a name. This chart has no name. The left column is n. It goes 1, 2, 3, 4. Cool. And then it says the sum. So we have, if n is 1, the sum is 1. If n is 2, the sum is 1 plus 3. What are they talking about there? Anybody have any ideas? So it seems what they did was they took this n and this n and put it there. Okay? So it's 1 plus 3. So they're going to drop that down, but right? 1 dropped down to 1 here. 1 plus 3 drops down again here. And then 3 plus 2 is the 5 there. Okay? And then 1, 3, 5 drops down, and 3 plus 4 is the 7 there. Okay? So let's erase that. So, because I don't know what the problem is actually about yet. But we're trying to get some understanding that what I just showed you about that may have nothing to do with it. There also may be issues where it's talking about the sum. So the sum of this is 1, the sum of this is 4, the sum of this is 9, and the sum of this is 8, is 16. Okay, so do you see any pattern there? It's n squared. 1 times 1 is 4, 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. That's supposed to be a 6. Okay, so maybe that's what they're looking for. We don't know. And I often say sometimes on some charts, there's a total at the bottom here, but I don't see any point in adding 1, 2, 3, 4, and I don't see any point in adding 1, 4, 9, and 16 either. So that's probably not something that we're looking at here. It's not that kind of a chart. Okay, it's obviously a pattern. Okay, it's going to be an arithmetic sequence in particular if we're talking about terminology. Okay, so we beat the illustration to bits. So let's go back to the words. A student formed a pattern. Cool. That's what we thought it was. In which each term is represented by a sum. So we analyzed what that was about. I think we understand that. The first 4 terms of the pattern are shown below. 1, 2, 3, 4. Cool. Which expression can be used to determine the value of the sum in any term n? Well, I think we answered that by noticing that it was the square. Okay? Because once we saw this column, it was clear 148 is 1 squared, 2 squared, 3 squared, 4 squared. And this middle part, let me change the color there. Let me make that yellow. This middle part here is almost kind of a distraction. They kind of forced you to do the 1, 4, 9, and 16 on the side. All right? So that's what makes this problem hard. It looks like there's something in, let me change the color again. It looks like there's something significant in this column. And there's not, except for the total of it. Okay? In fact, the kind of pseudo hint we get is that it says sum. All right? So it's almost kind of tapping us on the shoulder and saying, yo, bro, add this up. Okay? But we don't know. We don't know where it's going, and that could be misleading. And by the way, that's one of the issues. Even though while I'm live here, I'm thoroughly analyzing all the illustrations. I'm only doing that to kind of elucidate for you guys so that you know kind of you need to span that full spectrum if you need to. That's number one. Number two is that when I do this analysis, I could talk about it for 5 minutes. But if I actually sat down and did problem number 19, that analysis might only take 5 seconds in my head. Okay? The third thing is, as you get used to the different kind of questions there are, you're gonna know what's important or not, or at least have a good guess for it for most cases. Okay? So even though I do a thorough analysis, show you all the alternative choices to interpreting the illustration, in a real problem, you may not do that completely. Okay? All right? Like I said, let's use this as an example. On some things, the total might end up being important. Okay? It would serve me no purpose to robotically just total this up. Okay? And enough of them, I should not even be thinking, what is the total? Because they might not ask me that. But it's important to me to understand the problem. So usually I'm asking myself some questions that are not directly related to solving the question or whatever it's going to be. Because I haven't even looked at the question yet in most cases, right? So there's that yin-yang and issue. Build up your mathematical fluidity and prowess and savvy. You kind of get a feel, and in some cases you're gonna overanalyze the illustration, and sometimes you're gonna underanalyze it. Okay. The real point of looking at the figure first is that a lot of kids will zoom through the words and then look at the illustration even faster. So I'm forcing you guys to look at the illustration first. There's no hard rule that this guarantees you to get the right answer. Okay, it's just a technique. It actually works for my brain, and it works for a lot of students I work with. It's not a guarantee. There's no guarantee you're getting the right answer. The only way to get the right answer is to figure it out and double check it and go back to the person who wrote the question, right? In this case, this was New York State, and see if your answer matches theirs for the right reason. Okay, sometimes your answer can match and be correct in terms of A, B, C, D, but you used the wrong technique to get there. You just got lucky. There's enough calculations that end up at 0. You may not have gotten 0 for the correct reason. All right. So let me just make sure we're live, so I'm not talking into the wind. So in this case, it's just n squared. So don't let stuff like this kind of distract you. Okay. And it's in a lot of teachers and tutors, oh, this is there to trick you. It's not there to trick you. It's not there to trick you. You know, if you're writing a program that's going to control the brakes to a car, I think you need to understand what the problem is. You know, if you're writing something involving the functionality of a medical device and it's hooked up to you, you're going to want to hope the person who did that and created that and designed that and analyzed that did all the right stuff, right? You don't want to be hooked up to something that's a joke, right? So part of what we're doing is taking something and giving it a serious look. And again, it doesn't have to take you hours to do that serious look. I'm trying to harp these things because that's, to me, more important than solving question number 19. Is once you're getting your critical thinking down, your analysis thinking cap on, right? And you're putting yourself in the right frame of mind. You don't have Discord in the background going blip, 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 right? Or checking your email every 30 seconds. You need to have time where your brain can think and you can solve a problem, okay? Okay, so we've seen a problem like this a few times already in grade 3, in grade 4, and in grade 5. Okay, so this we can already see fractions leaping out of this. So Jason will use a 1/3 gallon pitcher to fill a 3/4 gallon. So first of all, we notice this is gallon, that's gallon. So far there's no unit conversion. Remember to always consider that. How much water will he need to completely fill the water jug? Okay, so this almost, when I first read this question, I was like, huh? He would need 3/4 of a gallon, right? Isn't that the answer? How much water will you need to completely fill the gallon? But if you notice, the answer is not gallons. The answer is in pitchers. So then you have to give it a second read. He will use a 1/3 of a gallon pitcher to fill an empty 3/4 gallon water. So let's say, for argument's sake, we're gonna if if this was 1 instead of a 1/3, and this was 3, I think all of you would know the answer was 3, because all you did was 3 divided by 1. In other words, the total divided by the part, right? So if there was a 3-gallon water jug that you were trying to target, and you're filling it up with 1-gallon pitchers, you would just do 3 divided by 1. So the fraction, that these are fractions, 1/3 and 3/4, shouldn't matter. So what we're going to do is 3/4 divided by 1/3. By the way, this technique of taking a messy problem and simplifying it by using small whole numbers is really useful. I think in the series so far I mentioned it 3 times. Okay, I mentioned it maybe in grade 4, and I mentioned, I think, yesterday, and I'm mentioning it today. So this idea of taking harder numbers or uglier numbers and just simplifying them works wonderfully. All right, so coming back to here, division by a fraction is the same as multiplication by a reciprocal. Okay, so this is equal to 9/4, which is equal to what? 2 1/4. Okay, so there'll be 2 full pitchers plus 1/4 of another pitcher. Okay, even though it's remember the pitcher we're going into is the full pitcher itself is only 3/4 of a gallon. So 1/4 of 3/4 means you're going to fill it up 3/16. Or they're not asking you for that, but I'm just going the extra step that you're going to fill up 2 whole pitchers and 3/16 of another one. Where am I getting 3/16? It's 3/4, and it's 1/4 of that. Of means multiplication. So 1/4 of 3/4 means 1/4 times 3/4. So 1/4 times 3/4 is 3/16. Okay. All right. So so if you notice, this is about a half. That's no good. This is about 1/4. That's no good. Between 2 and 3, yep, it was 2 1/4. So they're not looking for an exact number in this example. And you can almost guess it too, because if the smaller pitcher was 1/3, and you're trying to fill out 3/4 of a gallon, so now we're just going to approach this logically, like how can we kind of double check this without doing it, like with strict digits and numbers to prove it. So if it's 1/3 of a gallon that you're pouring into 3/4, 3/4 is about 1. We're gonna approximate here. So three of them that are 1/3 would be 1. Okay, right? 1/3 plus 1/3 plus 1/3 is 1. So 3 of them would fill up 1. So since 3/4 is less than that, then the answer has to be less than 3. Okay, and I think enough you should be able to know if it's 1/3 plus 1/3, that's 2/3. 2/3 is less than 3/4, and you have to know how to do that, right? For those who don't, we're going to fill in the relationship here. 3/4. Okay, there's a few ways to do that comparison. You can create like denominators, make them both 12s, and compare it. So if this is a 12th, this is 8/12. Okay, times 4 times 4. If this is a 12th, this is 9/12. So that means we're doing that. Okay, you can also do the cross product. If I do 2 times 4, that's 8. And I write the answer to that multiplication on the top, the numerator that's at the top of the line you drew. So this is 8, and then 3 times 3 is 9. Okay, so it still shows this is greater than, all right? All right, we took a couple sidebars there. So the answer is B for 20. And again, we might do a part 5 to this. Let's see how, because some of the examples are they're not all super duper hard. They're or lengthy, if we put it that way. So there's an illustration, supporters at a football game. So this is a pie chart. That's what this round circle with different colored areas, especially when there's numbers or percents in it. So 20% is the visiting team, and 80% is the home team. So we just know that 20%, it says supporters. So 20% of the people there at the football game apparently supported the team that was not the home team, and 80% didn't. So what I like to do is just in my mind, and I wouldn't necessarily write this, 20% is the same as a fifth. Okay, and 80% is 4/5. So you should know that. This deals with your numeracy and your numerical fluidity and other stuff like I was talking about every time I do this series. So that maybe that's going to come into play here. And if it doesn't, at least you're understanding kind of the magnitude of the visiting team versus the home team. All right? So that when you finally pick the answers down here, that you have some sense, like could that even make sense? Right? That kind of a thing. Because just to leapfrog down here, it's telling us to 64,000. So for instance, if they ask how many people are on the visiting team or supported the visiting team, you know it's 1/5 of 64,000, right? So you know if one of the answer choices was like 2,000, that can't possibly be the answer. Because 1/5 of 64,000 is at least 10,000. So the answer can't possibly be 2,000. So you have this kind of mathematical thing going on that you should be completely aware of, being astute of it. This deals with your mastery. So that, and plus, if you make a silly error in the solution of your problem, and it kind of flies out your brain, oh, I wasn't sure, I didn't realize I made that silly error. This kind of double checking, just approximating and reasoning it out, is giving you kind of a radar detector, if you will, right? Once you pass 60, you go bleep, 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 that kind of thing. That's what you're doing here, right? The radar detector might also say your exact miles per hour, but like if you're doing 80 or 90 and a 70 mile per hour, it's going to beep for both of those, right? It might beep faster when it's 90, but you're still getting some flavor of, hey, yo, I'm past the speed limit. So this is the same kind of thing where we're just trying to get some sense out of this and make logical sense of it. Okay, so let's actually go to the question now. The diagram below shows that the percentage of people attending a football game who were supporters of either the home team or the visiting team. Cool, the most awesome thing I've ever read in my life. Okay, and it confirms what we just said about this. So if the total number of people attending the game was 64,000, how many people were supporters of the home team? Okay, so probably the first error here is enough kids are going to choose the visiting team. Okay, so what you're looking for those kids is they would have done 64,000 times 20%. And 20% means 20 over 100. And you would cross out your zeros and all this stuff, and you would get to 12,800. But they're not asking about the visiting team. They're talking about the home team. Okay? Let me get rid of that because I want to keep that 80% visible. Whoops, what did I just do? Why is this not erasing? Come on, bro. Erasing that? Yes. Okay, there we go. All right. So something's wrong with this application, I guess. All right. So it's asking how many people were supporters of the home team. Okay. All right. There's another way to do this, which is that most of us can work better in units of 10, right? So if the total number of people here was 64,000, how much is 10%? So 10% just means throwing away a zero. So 10% is equal to 6,400. Okay. So if they're looking for 80%, we're going to multiply that by 8. Okay. And the answer turns out to be 51,200 when we do that. All right. So in case you make a mistake here, if we look at this without actually doing the multiplication, if we did 6,000, let's estimate it. If we did 6,000 times 8. So what I'm doing for this example is I'm actually avoiding solving the real problem, and I'm trying to show you like a smart way to address it. So this would be 6 times 8 is 48, right, with 3 zeros. So right there you know, because it's not 6,000, it's 6,400. Right there you know that the answer can't be A, the answer can't be B, and the answer can't be C, because you haven't even accommodated the 400 part of it yet. So this problem you can almost solve in your head. Not that I'm saying that you should do that, but you should have it should leap out at you. That's what this problem is asking you to do, right? Okay. You can also use the 4/5 that I was mentioning before, because so make sure when you use fractions like this though that they are actually correct. So 20% is the same as 4/5. I mean, sorry, 80% is 4/5. So it's 4/5 of 64,000. Okay. Personally, I think multiplying this by 4 and then dividing by 5 is probably the longest and slowest and most tedious way to do this. And perhaps you can throw an error in here too. The good news is if you made an error, you probably wouldn't accidentally get 48,000. So you would get something close to 51,200 and say to yourself, oh, I goofed up here. So that's the good news with this problem, is that the spread between A, B, C, D is 12,000. It leaps all the way to 38,000, leaps all the way to 48,000. 51,200 is close to 48 in terms of being, compared to 12 and 38, A and B. But they're still far enough apart that you could probably see the error in your ways and then backtrack. Where did I exactly make that mistake? Okay. And if you want, as a double check, let's say you did the calculation and you got the 51,200. If you want, you can also calculate the 20% and get to 12,800. And then if you add those together, if you add 12,800, because we always want to have ways to double check your answer. If you add the 12,800 and the 51,200, okay, are you going to get to 64 back? And that's the kind of thing you'll want out of this, all right? And it should come to the 64,000. So you have checks and balances that can always completely alternate ways. If you have, a multiplication, you could take your answer here. Let's say you had 51, 200. You should be able to work back to the 64,000 that way, just by reversing the operations that you did. All right. So there's lots of possibilities here. Okay, this is kind of a horse of a different color question. It's rarely kind of seen And in some ways, it's too obvious a question, which might be why enough kids get it wrong. And it's the way it's worded that can throw you off. So it says, which pair of expressions is equivalent to any variable value greater than 0? What do they mean, any variable value? What are they talking about here? Any variable value? What? So let's look at it. We have 3 times x plus 2, and then 3x plus 2. Oh, I see a variable x and a variable x there. B has 4d plus 2e and 8d plus e. So there's 2 variables there. F is C is FFF plus G and 3FG, and D is B plus 3C and 2B. So some of them, like A only has X in it. Okay, so they want to know which expression is equivalent to the other. So there's 2 expressions in each, and we need to know if they're the same. So what happens with some kids is it says any value greater than 0. So what they're going to go do is plug in a number here. So if we make x 1, right? For this over here, we're going to get 3 times 1 plus 2, right? So that's 3 times 3, or 9, right? And then for 3x plus 2, we're going to get 3 times 1 plus 2, and get 3 plus 2 is 5. So we're going to say that's not the case. But solving the problem by plugging numbers in is getting way too close to the problem. There's some problems where you want to kind of back off and kind of look at it. Okay? So let me clean the screen and show you what I'm talking about here. So first of all, recognize that it says that the value is greater than 0. That's cool. Okay? But when you see something like this, is this not A times B plus C? Is that not the distributive property, which is equal to AB plus AC, right? So does this look like AB plus AC? If we'd apply the distributive property to this right here, that's 3x plus 6. But this says 3x plus 2. So no way. Doesn't work. Okay? So let's approach B that same way. Okay? So that we're not going to plug in values. And there are some examples where plugging in values is the right way to do it. But in this example, it's going to waste your time, and you're getting too close to it. So if there's 4 D's here, this says there's 8 D's. And if there's 2 E's here, this says there's 1 E. Well, that's no good. It don't work. Okay? It doesn't work. They're not the same. One has 4 more D's and the other has 1 less E. Okay? This is 3 F's, F plus F plus F. This is not multiplication times G. I mean plus G. So this is 3F plus G. When I said a second ago this is not multiplication, I'm talking about this. So this says 3 times F times G. So it's not that. Okay? And this says B plus B. Well, that's 2 B's. So 2B plus 3C equals 2B plus 3C. Voila. And you lived happily ever after. Okay? All right, how are we doing on time here? Because I'm going to decide in the next 2 problems whether we should, we're 39 minutes. Okay, so we're probably going to, I think I'm going to split this into 5 parts, which is good. It's good to have bite-sizable little snippets of these things here. And I can pace myself too, because we still have, let's see, we did about 25 pages worth of problems so far, and there is still about 16 left. So my average rule of thumb is to be able to get through 10 pages per hour and to an hour and a half. And if we do all this, there's probably another hour and a half still left. So let's try to get 4 more pages done and see where things end up there. And once in a while, some of these examples are bing, bang, boom. And the goal here is not to get through as many problems as possible in the fastest amount of time. Okay, we're trying to explore, we're trying to learn, we're trying to think, right? So, anybody coming into this now, if you're catching this on the replay, please smash the like button. Please subscribe. I'm pounding out a lot of these, and this is to your guys' benefit. Also, if you're catching this on the replay, you can pause and see how I solve it, and then see if your answer is the same, and then sit around and get some popcorn and watch as I do the other exploration. All right, so Rosa has a running goal of 100 miles this month. So that's her goal. For some reason, that's important and significant. Each day, so we went from month to day now. Each day that she ran 5 miles. So I'm going to write that out. 5 miles per day. Okay. I don't know where this problem's going, so let's go back to it. She wants to run 100 miles. Each day she runs 5. Okay. Which expression could Rose use to determine how many miles she has left to run after running D days? So this is 5 miles per 1 day. Okay. So she's trying to get 100 miles. So let's play some numbers here. So instead of running D days, let's say she ran. Let's do a hypothetical. And again, I like to use either small numbers or, in this case, a factor of 10. So if she runs 10 days, actually, I don't want to put that. She runs 10 days. Okay. How far has she ran? Well, this second sentence here says each day she runs 5 miles. So in 10 days, she ran 50 miles. Okay. And now the question is, how many miles does she have left? So isn't that 100 minus 50? If her goal was 100 and she actually ran 50, then she has 50 left. And that would be the end of it. So which thing here seems to map into that? Well, this is 100 minus something, which is what we did here. So far we're okay with A. Minus 5 times D. Is that not what I did? Right? Did I not say it was 10 times D? And D was 5. So 10 times that is that not what I did? So it looks like the answer is A. Okay? B says it's 5D plus 100. Well, she ran 10 days, it would be 50 plus 100. That's 150, that's no good. Okay? C says 100 divided by 5D. So if she ran for 10 days, she ran 50 miles. Be 100 over 50. Is that 2? No, that's no good. Okay? And then D just says 5 times D. I mean, if she ran for 10 days, she ran 50 miles. No, that's not how many she has left. That's how many she ran already. So it's not that. Okay? So we can plug in numbers and get the value. So now let's look at A again. Let's look at it conceptually. Okay? So instead of actually using concrete actual numbers, let's look at this abstractly. Okay? And let's go backwards, actually. So if we look at D again, it's 5D. 5 times the number of days that she ran. Right? It says after running D days. So if she ran D days, is 5D how many she has left? No, 5D is the number she ran. So we can't do that. If we look at C, if we know from just talking about here that this is what she did run. So is it 100 over what she ran? No. Imagine you were getting change back from if you bought $50 worth of something and you gave a $100 bill. I don't think you're going to get change back of 100 over 50. That's not 2. So this is conceptually invalid as well. Okay. B, Let me erase that in case you can't see it. Is 5D plus 100. So is it the amount she ran plus the goal? Huh? How could she run over the goal? Right? So this is conceptually nonsense. And A says she wants to run 100 days, subtract from that goal total the actual number of miles she ran, which is 5 times the number of miles she runs per day. That's what D is. So booyah, booyah, booyah. Okay, 39 might be foreign to a lot of you guys. There's the notion of a set. So if we look at the illustration here, the illustration is this here. This line here. Okay? And set notation is normally avoided in New York City schools and probably in New York State in general. I'm just familiar with New York City. It also just generally seems to be avoided in most standard math classes, unless you're in the accelerated class or the honors class or the gifted and talented class. And it normally goes like this. A variable, like a list, equals, okay, and you put this curly brace or squiggly, which is your shift. It's the key next to the P on the Dvorak keyboards. If you shift the left square bracket, you get the left squiggly bracket, and the key next to that is the right-hand side. And then you put your list, like 1, 5, 7, and then you close the list with a closing curly brace. Okay? So that's the notation for list. Okay? If we get rid of the L equal, this is still a list, it's just not named. It doesn't have a name, because there might be certain things we're doing where there's 2 lists. Okay, so we could say M is equal to curly brace 1, 2. Okay, and then we can talk about set L and M together maybe. Okay, but that's not what this problem is. So that's the notation. It's hard to see this. That's a curly brace. That's a curly brace. So there's 3 members in this set. 0, 0.875. Sorry, there's 4. 1 and 2.5. Okay, and this is super tiny and it's annoying to read. Even the question at 5.6 plus the 0.4c, it's all jammed together. Right, that kind of a thing. And you can't blow up your test page. Although if you're taking an online problem, you can probably get it to expand. All right, so a couple of things here. So the illustration is showing us a set. It's showing us decimal numbers and integers. Okay, there was 4 members in this set. The set doesn't have a name, and the numbers are in least to greatest order. Okay, and that doesn't need to be true here. I could have a set that's like -1, 5, 0, -2. Okay, it could be anything. It also can contain decimals. It can contain fractions. It can contain negative numbers. So we're cool. It could even add something like pi in the middle of it, or the square root of 3 could be one of the choices or whatever. All right, so we can get stuff like that. All right, so that's all we know about this. Is this 4 elements and they're ordered? Okay, so now let's go back to the question. And what I'm going to do for now, I'm going to erase what I did here because this is more teaching than tutoring at the moment. Just for those of you who don't know what this illustration was trying to show us. And normally sets get talked about in June when the teacher has run out of time. And it's normally one of those topics that are just kind of thrown out there. And sets are important. Set theory and number theory are significant things in math and also in the real world and so on or whatever. Okay, so which value or values? So each of these 4 elements in this set are values, are a value, and then maybe 2 of them are values. Okay, from the variable C from the set. Sorry, I read that wrong. Which value of values for the variable C from the set below will make this true? So normally what happens is it's going to take one at a time. So what we're going to do is run through and make C 0 first. We're going to do this inequality, and we're going to plug in 0. Okay? Then we're going to do the inequality second time with 0.875. And then we're going to do it a third time where C is 1. And then we're going to do the inequality a fourth time where C is 2.5. Okay? So this is a tedious problem. It's really super terse, and it's nasty in the sense that there's 5.6 and 0.4. Okay? So let's take each in turn. So we have 5.6, and I'm going to make extra care to do this neat, plus 0.4C is less than or equal to 6C. Okay? So we're gonna take each thing one at a time. So we're gonna start with 0. So we're gonna get 5.6. That's still 5.6. 0.4 times C, which is 0 in this case, is 0. This tablet is not keeping up pace with me. I don't know why. It used to. Okay, again, we're doing 0. So 0.4 times 0 is 0. So plus 0, okay, is less than or equal to 6 times 0, or 0. Okay? So is it true? What did I just do? I typed this wrong. So is it true that 5.6 is less than 0? No. All right? Okay, so now we're going to plug in the second choice, which is 0.875. Okay? That's a nasty number. So I'm going to bypass it at the moment, just because it's ugly, and try 1. 1 seems like a nice, beautiful number to do. So we're going to do 5.6 plus, if C is 1, then it's 0.4 plus of it is less than or equal to, and if C is 1, 6. So 5.6 plus 0.4 is 6. So is 6 less than or equal to 6? Yes. So 1 is one of the choices. So let me give us a green for good. So 1 is good so far. Okay? That means A is no good. So we just ruled out A right there. Okay? Because the only choices with 1 is B, C, and all. Okay? But let's just double check that. So if we try 2.5, okay, we have 5.6 plus 0.4 times 2.5. That's 1, right? Because we can do 25 times 4 and get 100, and then move the decimal place over twice, right? 2.5 times 0.4 gives us 100. And we move the decimal place 1 for the 4 and 1 for here. So if we get 100, boink, boink, we get 1.0001. And then less than or equal to, so 6 times 2.5 is 15. Again, you should be able to do stuff like that in your head, but just do it on the side. 2.5 times 6. 6 times 5 is 30, 0, 3. 6 times 2 is 12, plus this 15. And we move the decimal place over 1 for there, and we get it here, so 15. So 5.1, that if we come back down to here, plus 1 is 6.6 is less than or equal to 15. All right? Oh, that turns out to be true. So before I said to rule out choice A. Sorry about that. So far, 1 and 2.5 work. So far, that's good news. So this works too. Okay, 0 didn't. So now we have the nasty 875. Yuck. Okay, so this means, so since we know the answer is at least 1 and 2.5, it can't be A. Okay, we know 0 is no good, so it can't be D. So now the question is it B or C? Right, so we're onto the critical line. First of all, you should know your fractions, that 1/8 is equal to 0.125. If you don't, this is something you should definitely bump your game up, which means 7/8 is 0.875. And that turns out to be what this number is here, right? So this is 7/8. So that's another way to look at this, that this is 5.6 plus 0.4 times 7/8. Is less than or equal to 6 times 7/8. Okay, it doesn't make the problem any more easier. The alternate way to do this is 5.6 plus 0.4 times 0.875 is less than or equal to 6 times 0.875. Okay, I'm not going to do that multiplication. I'm not going to do the fraction one here. It turns out when you do them, that 0.875 is no good either. And that the answer is B. Okay? If anybody needs to prove that offline, we can do that. But this I can't get a finer, I need to get a finer point with this tablet. I'm not sure what happened. I'm gonna have to reinstall it or something. All right. We're still live here. Yes, we are. We're going about an hour. So I'm gonna do maybe 1 or 2 more problems, and then we'll do a part 5 to this. That's both good and bad. Okay, we're gonna do our traditional. We're gonna just look at the illustration. There's this weird looking thing here with flaps on it. You could, if you want, interpret this as a composite shape. That we have A, B, C, D, and E. There's a lot of ways to look at this problem. We don't know which way to look at it yet. And it doesn't matter what order I label this, A, B, C, D, E. That's just what came to mind. I see a whole bunch of numbers. That's 8. That's 3. That's 3. That's 4. That's 5. That's 5. Okay, so there's all those numbers flying around there. So let me just get rid of those again, because we're probably going to need to use them. And it looks like it's another net, right? Because we see the dotted lines there. So it's probably something folded up. And let's see if I fold it. E looks... Okay, I was trying to look for symmetry. It's not symmetrical, because the height of A is 3, the height of D is 4, and the height of E is 5. But it looks like it's a pyramid. Sorry, a prism. But the lengths, the widths of each little side is not the same, okay, which is fine as long as it can fit. So in other words, the one side with 3 and the other side with 4. Let me erase that to make sure you guys can see that still. The one with 4 is gonna span across there. So we're gonna have something more like that, I guess, on both sides. When we fold this over. So this thing right here, this little flap is B. This little thing here is C, right? And then D is gonna be this area right here. Okay, and then A would be this here. Okay, so let me get rid of that too, as long as we're visualizing all this. And again, you're doing this in seconds in your head. Okay, it might take me 5 minutes to show you all the nuances to this, just to make sure you guys are covering the bases. We still don't know what the question is. I do notice that it gives me the 8 across. It gives me the 3. So every coordinate matches. I mean, we don't know yet because we don't know exactly what shape this is, but it looks like it's a prism. But so that probably means this is a 5. It probably means this is a 5. It probably means that's a 3, and it probably means that's a 3. Okay, because that's the way it works, and it means this is an 8 too. Then, okay. So let's double check that with the words now. They're probably going to ask us for the surface area again. I'm just doing a random guess, just based on being familiar with these, and you guys have seen a couple already, so that seems to be the direction they're going. So let's go back to the words. A net of a triangular prism. So yes. So we're guaranteeing it is a triangular prism. Okay. And by the way, if you looked at it from the side, and this would be behind her, I guess. Right. And you really wouldn't necessarily be able to see the back, but so that's what you're going to get out of there. So this bottom part here would be D. The one side here would be, and this triangle on the side would be B or C, whatever, depending on how you looked at it once you folded it up. Okay. What is the surface area of the triangular prism? So there we go. All right. So we did a lot of yin and yang back and forth to be able to get to that point. So it gave us 4 choices: 44, 96, 108, and 120. So what we can do is take the composite shapes and get the surface area of each of those. So A is 8 by 3, or 24. Okay. D is 8 by 4, or 32. Okay. E is 8 by 5, or 40. Okay. So we can add those up. We got 72, 82, 92, 96. So we're going to get 96 plus the 2 flaps. So each flap is a triangle. It's 1/2 BH, right? Or we can consider that C, if we bring C over here, it's just the area of a rectangle. 5 times 3 is 15. All right, so 90, what did I say before the number was? 70, 80, 96 plus 15. Let's see, I made a mistake somewhere. What did I do? 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Yes, I did. I made a mistake. I said the area of this here was 15 because I saw that 5. But the height is actually 4. So that's 12. So it's 96 plus 12. Okay. And 6 plus 2 is 8. And 9 plus 1 is 108. Okay, so that gives us C. All right, so I goofed up. So if this was a grid-in, I probably would have gotten this wrong. Or if this was a show you work problem, I may have gotten it wrong. Okay, never me, right? So this is the kind of stuff you have to watch out for. So there's all this busy stuff going on here. So I'm going to present a second way to do this, which is still based on that. Let me erase everything one more time. There's actually more than a second way to do this, because we could also look at this, this right here. Is a trapezoid. So we could have got to the area of the A, then the area of the trapezoid, and then the area of the C. And the area of a trapezoid, you should all know this too, is the base, the first base, plus the second base, the average of those two, times the height. So in this case, the height is 4, and we would have 8, right? This is 8, and the length of here is 3 plus 8 plus 3. So we get 8 plus 3 is 14. So we'd have 14 plus 8 is 26, over 2 is 13, right? And then we'd have 13 times 4. So we get 13 times 2 is 26, and then we would get 52 here, right? So that's another way to approach this. All right, and then add those up too. And the other way to do it is still another way. And that's the beauty of math, that there's often a whole bunch of ways to do it. In this case, this is geometry, a geometric shape, that we're using composite shapes, which is different shapes built up to do that. The other way to look at it is this whole thing here. Okay, this is 8 times 5 plus 4 plus 3, right? 3 plus 4 is 7, plus 5 is 12. So this is an 8 by 12. And that's 96. And then we can add the 2 flaps back into there. Okay, so we still get the same numbers there. All right, we're going to do one more page and then be done. Call it a day, call it a night, call it an info session. Okay, 2 whole numbers. So it's not a fraction, it's not a decimal, it's not a rational. 2 whole numbers have a least common multiple, an LCM, of 60. The least common multiple of 2 numbers is 60, right? The least common multiple. I'm not gonna go into a spiel of what a least common multiple is here. If you don't know, look it up. There's greatest common factor and least common multiple. In fact, I have a whole bunch of videos about both of them and how to compute them. So there's probably about 7 altogether. I think I did 3 or 4 about least common multiple and 3 or 4 about GCF. In fact, I think I did somewhere they were together as well. So go back and look at those, and you'll be afraid you looked, because I cover them pretty in depth. Okay, 2 whole numbers have a least common multiple of 60. Each number is less than or equal to 12. Okay? So that means the number is basically from 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The greatest common factor of the 2 numbers is 2. Oh, man. Right? So what are the 2 numbers? What are the 2 numbers? What are the 2 numbers? Right? So what is the least common multiple of 6 and 10? Okay, it's not 60. It'd be 30. Okay, so for that reason, A is out. Okay, B, 5 and 12. Okay, its LCM is 30. Is 60. Okay, and I'm not gonna rip apart the GCF and the LCM of these in this example. Again, I have enough videos with these that I strongly recommend you guys go look it up. Okay, so the LCM is 60. The greatest common factor of the two numbers is 2. No, 2 is not a common factor from 5. So B is no good. Okay, the LCM of 10 and 12 is what is that? Trying to do this in my head. My mind's going blank. Oh, it's 60. Because 30 is no good, 60 is good, 120 is too large. Okay, and the greatest common factor, if we factor 10, we get 2 and 5 and 1 and 10. So 2's in there, and 2 is also in 12. So booyah, it looks like it's C. Okay, and if you look at D, okay, this greatest common factor of 15 can't include 2. So for that reason, D is out. Okay, so there we go. That's C. All right, guys. We're going to continue the next time. My brain is hurting. This has been a long week for me, actually. Well, we're getting some messages here. It's Park Heng Young. What do you have, multiple accounts? Yeah, okay, on a different account. Hello. Yeah, I'm just ending up now. Subscribe and like if you haven't already. Well, you must subscribe or you wouldn't have known about it. So like this. Everybody like this. Come on. I put in a lot of energy and work for you guys. It's the least that can happen. Yeah, I'm done. We're gonna do a part 5 to this, and then flip into the grade 7, which might have 3, 4, 5 parts as well, and then grade 8 as well. I might postpone those 2 slightly until next week. We have to see, because of what I want to do too is start doing some sessions that lead up into the SHSAT, that lead up into SIC, that lead up into the ISEE. What happened was because of the pandemic, a lot of standardized tests got delayed for a long time, and it's almost like they went up into the next testing season, the next prep season, and I guess that is what happened. Because the SHSAT is normally in late October or early November, and yeah, the state test was more or less on time, but even that got pushed back because it's normally in March, April. It ended up being in April, May. Although the state test they didn't do properly this year. They watered it down a lot, and they gave the problems that were existing on other state tests. So it's a mess up. No, I have no indication that they're going to cancel it. And they have proof of concept. I don't know what the DOE dragged its feet on so much for, but they did it, and there was no problems. And in fact, I think they should have always done it that way, even without a pandemic. So you gotta go with the flow, so to speak. There's always debates. There's always people making statements. Some of it's political. Some of it's representative of the state of affair of education. So it's confusing. Yeah, I agree. I try to keep this channel racially agnostic. But yeah, there's issues here that I think can be improved, which is, by the way, one of the reasons why I do this channel. That I give so much material for free here that all somebody has to do is sit down and follow with me. I'm not charging anybody for this. And if you want to learn, you sit down and learn with me. So for somebody to say that I'm doing the wrong thing by helping you guys with math problems, I can't perceive that. I'm about uplifting everybody, no matter who you are. So, and I don't agree with unlifting somebody, the reverse either. Equality and equity is not about everybody being exactly the same. That's not real. It doesn't make sense. We're not socialist. We're not zombies living in an apocalypse. Everybody's different. Everybody has different skills. So there you go. Yeah, I mean, call me what you want. Call me a Samaritan. Call me a curse word. No matter how you do it, I'm just trying to be generous and giving back to the world, if you will. This sounds corny, and it might even sound egotistical, but that's literally what I'm doing. There's nothing more. While everybody's arguing about fixing schools and whatever, I'm out here pounding out some math problems for you guys. So, all right, I don't want this to get too political, so I'd rather focus on the ELA and the math and just getting you guys to be happy, concerned citizens, and so on and so on. All right. So I do think there's going to be an SHSAT. Um, whoever knows, this is a debate that's been going on for decades, 50, 60, 70 years. Um, you know, all I can say is I'm putting my best foot forward to help people, and that's what more can you ask out of somebody, right? So, um, yeah, no, there's nothing to be sorry about. That's the way the world works. Um, you know what, too, and I've said this on other streams. I'm proud of you guys that anybody is caring and concerned enough to come on and join my streams. Not for me, but for yourself. That you're trying to improve yourselves. And when I hear uh, part of the community or part of whoever they are saying things like poor kids can't learn and poor kids are disenfranchised and they're not wealthy so they can't get tutoring. I'm sorry. I'm on here right now. I'm doing this. So I cannot buy that argument. I just can't. Is it completely false? No, it's not completely false. But it doesn't mean that those students have no opportunity. And most of you guys I work with on the internet for free are some of the hardest working people I've ever seen in my life. And you're only 12, 13, 14, 15, 16, 17 years old. That's amazing. That's amazing. You're not even adults. And you're taking on the responsibility to further yourself. Some of you have parents that can't speak English. And it's up to you guys to kind of chart your own destiny. And the beauty is you're doing it. And so maybe the last thing to say is I'm really proud of you guys. And you should be proud of yourselves. Okay? All right. Enough of this. All right, guys. Peace out, and everybody have a great day.